So we discuss now examples of integration. So I'll start with fourth example. Find antiderivative. Antiderivative means integral of the function fx equals to 4x cube minus 6, and where you are given that f of 0 equals to 3. This is given to us. So here fx equals to, that's antiderivative, equals to integral of fx. So 4 into, x raised to 4 by 4 minus 6x plus c. This is given to us. Big fx equals to this. So this 4 will get cancelled. X raised to 4 minus 6x plus c. Now we find this constant of the integration using the condition and we'll place there. Right? We just find c and we'll put into this equation number 1. What is given? F of 0 equals to 3. So I'll put 0 here. So this become f of 0. Here this is 0, here 0 plus c. But what is f of 0? That's 3. So c equals to 3. So therefore, by 1, you will get the required function. That is fx equals to x raised to 4 minus 6x plus 3. Using the condition, we just got the unknown c. Okay, next I'll go to example number 5. There first two sub questions are very standard. I'll go to fifth example with third sub question. Integral of 10 raised to 4 root x into sec square root x upon root x dx. So just by writing the question, you must have noted that the derivative of 10 is sec square. So we need to put some substitution. What's the substitution? You take this as t. And you also know that derivative of root x is 1 upon 2 root x. So I'll take 10 root x equals to t. Once you take the substitution, you need to differentiate this. So sec square root x, by chain rule, derivative of root x is 1 upon 2 root x into dx equals to dt. Now everything is there, you can see, just this 2 is extra, so I'll take on the other side. So sec square root x into 1 upon root x dx equals to 2 dt. So therefore, I means above integral. This much becomes, 2 dt. So that 2 will go out. This was t. So t raised to 4 dt. And now just you integrate this. What's the integral of t? That you know. T raised to 5 by 5 plus c. And now finally put the value of t. What was t? That is 10 root x. So 10 raised to 5 root x plus c. That's required integral. Okay. Now next I'll go to example number 6. In the sixth example, you have product of first sub question. Let's see. Sine cube into cos square dx. Now if you have product of sine and cosine with integers power, normally you should put the function where the power is even. So put cos x equals to t. This is very standard method. Put even power function equals to substitution. Which function has even power? Cosine has even power. So I'll put cos x equals to t. For example, if I have this, other way around, sine square cos cube x equals to t. Now which function has even power? cosine. So in that case, you should put cos x equals to t. Right here, oh sorry, here sin x equals to t because sin x has even power. Here cosine has even power. Okay, so let me now differentiate this. So if I differentiate, what's the derivative of cos? Minus sin x dx equals to dt. Minus sign is extra. Out of 1 sine cube, out of 1 sin x out of cube used with dx. So here you are left with sine square. It's like this, remember. Sine square x into sine x. So here 1 sine x is used with dx. So you are left with sine square. And that sine square you can write as 1 minus cos square. So 1 minus cos square x. This is nothing but t square, and 1 sine you have used with this minus, I'll keep outside here, this is dt. So minus 1 minus t square into t square dt. So I'll keep minus outside, this is t square minus t raised to 4 dt. Right? Now integrate this. Minus sign as it is. What's this? T cube by 3 minus t raised to 5 by 5 plus c. So minus what was t? That is cos x cube by 3 plus cosine raised to 5x by 5 plus c. That's the required integral. Again repeat, if you have even and odd power, you take substitution equals to the function whose power is even. So here I chose cos x equals to t. When you have this function here, which function has even power? That's sine. So I'll put sine x equals to t, remember, and then you can continue as I did here. So that's why it is important. Now the next question, question number 2, second one, their integral of sine x upon sine x plus a. Now earlier you did such questions, if you remember. What we do, we set this angle there. So x is there, so I'll write plus a minus a upon sine x plus a. What I did, just have set this angle there, x plus a, adding and subtracting a. Now we expand numerator using which formula? Sin x minus y. So sin x into cos y minus cos x into sin y, that is sin a, upon sin x plus a. Now what's the next step? I repeat what I did in the numerator, just expanding using sin x plus y formula. So what I'll get? Sin x cos y minus cos x sin y. Now do individual division. This upon this. So this will get cancelled. You are just left with cosine a here. This upon this. So cosine a being constant, I'll just keep it outside. Integral of 1 minus sin a is constant. I'll keep it outside. Your cos upon sine, which is nothing but the cot of x plus a dx. Individual division. Cosine a as it is, what's the integral of 1? X. Sin a as it is, what's integral of cot x? Log of mod of sin x plus a. This is linear function, remember. Upon the coefficient of x. Upon the coefficient of x, which is 1. So this is required integral. Third one, which is we had such questions in exercises, 1 upon 1 plus 10x. So what I'll do, I'll reduce into sine cos, So here sine x upon cos x over here, and that cos will be in the numerator. Now what we do, we set this expression over there. So cos x, I need to set the denominator expression into numerator. So cos x plus sin x. If I add sign, I need to write minus sign. Now, when I do individual division, then what happens? This upon this gives us 1, but here you will get the sign alone. I need the function again cos. So I'll write plus cos x. Now if you notice here, sin will get cancelled, but cos occurs how many times? 2 times. So I need to put 1 upon 2 in front of this. So what happens? Now you can see it is same as the previous one. This is just a rearrangement. Right? This is very important step, remember. We had such questions in exercises also. I repeat, what I did, first I have set this expression over there. Then, if I add sign, I need to write minus sign. But this will be alone, so I need to add plus cos also. So how many times cos will occur? Twice. So I need to put 1 upon 2 in front of this. You just simplify, I'll get the above step. Now do individual division. This upon this gives us 1 plus cos x minus sin x upon cos x plus sin x. If you think for a while this second term, you can answer it very easily. 1 by 2 as it is. Integral of 1 is x. Now here what's the derivative of cos? Minus sin, and derivative of sin is cos. So this is f and this is f dash. So we'll get the log of mode of denominator expression. You know, f dash upon f, it's very standard formula. Let's see. Okay, so it's a good question. Now we go to directly example number 8. Let me go to example number 8 directly here. So in the 8th example, first one is very standard formula. Second one is 1 upon quadratic with minus x squared. So you might have noticed your answer will be in form of sine inverse. But we need to express this one as a sum or difference of the two perfect squares. So what we do here, you know, we had such questions. This is not difficult, but just to remind you, x square minus 2x. How do we get the last term? Coefficient of the middle term by 2 whole square. So this is just 1. So you are subtracting 1, so I need to add 1 here. Fine. This is very familiar to you. So this is 1 square minus, now this become linear function, x minus 1 the whole square. Now this is a square minus x square. So you know, this is that sine inverse formula, 1 upon root of a square minus x squared. This is linear function. So it is just sine inverse x by a. A is 1 here, so just sine inverse x minus 1 plus c. Which formula you have used? You know, 1 upon root of a square minus x square. What is 1 upon root of a square minus x square? You know, it is sine inverse x minus a. I have used this formula. Sine inverse x by a. Remember, I have used this. 9th example, second one. First and second both were about quadratic only. This, you know, every quadratic can be expressed as a sum or the difference of the two perfect squares. What we do normally in such questions, we make the coefficient of x square equals to 1. So I'll take 3 outside. So this is x square plus 13 by 3x minus 10 by 3. Now we express as a sum or difference of the two perfect squares. What we do is here, coefficient of middle term by 2, that is 13 by 6. You square it. So it would be how much if I square it? it would be let me write directly 13 square by 3 square, sorry 6 square, or 36. This is 169. How do we get this? You do half of this, so 13 by 6. So 13 square by 36. We have 169 by 36. Minus, let me write here 169 only. Minus 169 by 36 minus this 10 by 3 as it is. What I did, I've added this, I've subtracted the same expression. How I got this 169 by 36? Half of this, the whole square. Okay, now we just simplify this. So what about first three terms that you know? Now it becomes x plus 13 by 6 the whole square. This is a perfect square, that's why we did this. Now here we need to simplify. How do we simplify this? So I need to take the 36 as LCM here. So here you will get, finally, if you just take minus common and if you simplify, you will get the 17 by 6 the whole square. Now this is a linear function. This is like x square minus a square. This is like x. So use this formula. If you remember, 1 upon x square minus a square, it is 1 upon 2a log of mod of x minus a upon x plus a plus c. Use this and simplify. Just I wanted to explain this perfect square only. Which formula? 1 upon 2a log of mod of x minus a. X means this expression, remember. Your coefficient of x is 1. So you can do it. Next sub question there. In the 9th example, third sub question is about same quadratic only, but that's inside the square root. So 1 upon root of 5x square minus 2x. Okay. In earlier example, if you just go back to that example number 8, the example number 8, you had minus x square, remember, here it was. So answer was in sine inverse. Here you have plus x square. So answer will not be in form of sine inverse. It will be in log, you will realize. Normally in this quadratic questions, coefficient of x square should be 1 always. So I'll take 5 outside, so it will come as root 5. Here x squared minus, if I take 5 outside, this will be 2 by 5x. Now here only I'll just set the last term. What should be my last term? Now you know. Do half of this. So 2 by 5 by 2, it is 1 by 5. Square it. So 1 by 25. Adding this, subtracting this. Now this become perfect square. So 1 upon root 5. Here root of this much is a perfect square of x minus 1 by 5 the whole square. Minus here 1 by 5 the whole square dx. So now use this formula. This is, remember, linear function. So like x, this is like a. So this is 1 upon root of x square minus a square. So which formula? Log of mod of x plus the same expression. Use this formula now. X means this entire expression, remember, you know all these things. I'm just telling you or just reminding you. Okay. Next, I'll go to example number 10. Both are linear upon quadratic only. So there I'll just explain the beginning. You know how to solve such questions. Just look at it, example number 10. I'll just do the second one. Just to remind you, remember, I'll just do the beginning part. X plus 2 upon x plus 3 upon 5 minus 4x minus x squared. This is very standard type of the question, linear upon quadratic. So what we do, you know the procedure. We set the derivative of this expression over here. That's the question. So what's the derivative of this quadratic expression? It is nothing but the minus 4 minus 2x. So we'll set over there. That's what you need to do first. There are two steps if you remember. First set the derivative, then split into two integrals. If you just recall. So what's the derivative of this quadratic? Minus 4 minus 2x. We need to set this one over there. Your numerator is x plus 3. I need minus 2. So multiply and dividing by minus 2. So minus 2x minus 6. Then what I need? Minus 4. तो आप इसको rearrange कर सकते हैं. This I'll write minus 2. Minus 6 की जगह पे minus 4 चाहिए. So I'll write minus 4 minus 2. This is one way. There is some another way also by taking that AB, you know. Right? Whichever way you do, both are correct, remember. So now that x plus 3 is replaced by this, remember. So I equals to, I'll place this minus 1 by 2 into 2x minus 4. And I'll open the bracket. So minus minus will be plus and here plus 1. I've just opened. So instead of x plus 3, we have placed this. 5 minus 4x minus x squared. Now do individual division. Minus 1 by 2 will come out. 2x minus 4 upon root of 5 minus 4x minus x squared. Plus here 1 upon root of 5 minus 4x minus x squared. How will do the first one? You know it. Put the inside that root expression equals to t. So a dt हो जाएगा. 5 minus 4x minus x square को आप t ले लो. So minus 4 minus 2x into dx become dt. That's why we did this, that you know. So a dt हो गया. And then this is just root t. So it would be this much only. T raised to, this will go in the numerator. T raised to minus 1 by 2 dt. You know how to do this. How will do this? This already done in 9th question as well as in 8th example. इसका आंसर आपको पता है साइन इनवर्स के फॉर्म में आएंगे because you have minus x square. Set the perfect square and you just continue. I hope this you can do now. Okay. The next, what about example 11? That is just about simple partial fraction method. You can do it. 12 is again quadratic upon quadratic. I'll just show you one step there. In example number 12, it's quadratic upon quadratic, remember. Quadratic upon quadratic. It's quadratic upon quadratic. So what we do? We set the denominator expression in the numerator. X square plus 1 upon x square minus 5x plus 6. So what's the first step? Set this expression over there. So x square, I'll write minus 5x plus 6. I need this much. Now what extra I've chosen? Minus 5. So I'll write plus 5. And I have 1, यहाँ पे मैंने 6 लिखा तो minus 5 लिखना पड़ेगा. This much extra I've used here, so I've subtracted here, I've added here 6 minus 5, that's 1. This is very standard technique when you have quadratic upon quadratic. Now what about the first one? That's just integral of 1. Here you can take 5 common if you want. This is x minus 1 upon x square minus 5x plus 6. Now here you are through. This is just x. 5, you can call this as I1. And how will solve the I1? You know how to do this. There are two ways. You can take this as a linear upon quadratic, or you can factorize this x minus 3 x minus 2, and now you can continue by partial fraction method. Right? You know it. You did it number of times. The important part is this portion, how to reduce into standard form. In the beginning of this, you cannot use the partial fraction method, remember here, because powers are same. When you use the partial fraction method, see that the power of the numerator expression should be less than the denominator expression, and that happens here. Okay. Next, I'll go to example number 13 is about partial fraction method with repeated factor. So you can do it. Example number 14, it's very important. I have already mentioned it earlier. You just consider x square equals to y. Everywhere you see you have x square, x square, x square. I have already mentioned this when I did the exercise question. So your function will be y upon y plus 1 into y plus 4. Now use the partial fraction method, a upon y plus 1 plus b upon y plus 4. Right? And now get AB, and then before you integrate, put the value of y, that is x square, and then you do it in integration. Right? This is not the substitution, remember. We had such questions in the exercises also, you know it. So this is an important example. Okay. Next, example number 15 mein, what you can do is, let me see just beginning of example number 15. I'll just explain one step so you'll realize that the function is 3 sine phi minus 2 into cosine phi upon phi minus cos square phi minus 4 sine phi d phi. So you need to use the substitution, that's sure. Now how will use the substitution? देखो इतना dx d phi में चला जाना चाहिए. Now ये किसका डेरिवेटिव है? Cos का. So we take the substitution. What the substitution here? Put sine phi equals to t. That's your substitution. And a जो cos square है उसके जगह पे आप 1 minus sine square phi लिख सकते हैं. Right? If I take this as a substitution, what's the derivative of sine phi cos phi d phi equals to dt? So the above integral would be, this is here I have taken t, so 3t minus 2 upon 5 as it is, minus what's cos square? 1 minus sine square, so 1 minus t square minus 4t dt. Cos square is 1 minus sine square, so 1 minus t square. So what you will get from this? Minus minus will be plus t square. This is minus 4t, and 5 minus 1, that's just 4. Now this is which type the expression? Have you realized? This is linear upon quadratic. It's like this, remember. 3t minus 2. This is a perfect square. T minus 2 the whole square. So this you can do by, partial fraction method with repeated factor, like this. Here a upon t minus 2 plus b upon t minus 2 the whole square. Partial fraction method with repeated factor. Now compare the numerators. I'll just show you one step. Then you can find a, b and so on. How do we compare the numerators? Here in the previous step, numerator is 3t minus 2. This should be LCM in both the steps. So a into t minus 2 is already there. आपको square चाहिए, तो यहाँ पे a into t minus 2 whole square आएगा. And here already this much is there, so you have plus b. Now you get ab, place there and integrate it. That you can do further. So now example number 22, second one I'll do. E raised to x square plus 1 upon x plus 1 the whole square. So you might have realized we are going to use this e raised to x f plus f dash. It is e raised to x into fx plus c. You know this. We are going to use this here. So here what we need to do is, besides that e raised to x, we need to set function plus its derivative. So always in such question we try to set this expression over there. So x square minus 1, I've added subtracted 1 because it has two factors, plus 1, but 1 is there, so plus 2 upon x plus 1 the whole square. Now here do individual division, so this upon this, so you have x minus 1 upon x plus 1. It has two factors, 1 will get cancelled with this, plus 2 upon x plus 1 the whole square. Now you just need to verify by division rule that if I differentiate this, if I take this as fx, differentiate by division rule, you will see that this is f dash x. So here e raised to x f plus f dash, so e raised to x into fx. Fx means what? X minus 1 upon x plus 1 plus c. That is required integral. Now next I'll go to example number 38, because the other are just standard functions. So next is about definite integral. You have modulus function. So what we do in such questions, we get x for which inner expression becomes 0. So it implies x into x minus 1 into x plus 1 equals to 0. So you have three values of x: minus 1, 0 and 1. These are the values of x. So your integral should be splitted at minus 1. It already starts from minus 1. Minus 1 to next is 0. Then here 0 to 1. You know this is one of the standard property. And then here 1 to upper limit, that's 2. Now in this interval just you need to see whether this is positive or negative. So take any number from minus 1 to 0 and place there. For example, let's put minus 1 by 2. You put here minus 1 by 2. So this become minus 1 by 8 plus 1 by 2. So this would be positive. So if you drop the modulus, it would be itself. Okay. Take any number from 0 to 1. Place there and decide whether it is positive or negative. You will notice that it will be negative. Try. So x cube minus x. Take any number from 1 to 2 and place there. You will see that if I take any number, suppose I have taken 1.5, put 1.5 here, you will see that it is positive. So you have x cube minus 1. If inner expression is positive, then it's replaced by itself. In inner expression is negative, you have minus sign in front of it. Now as usual, you just integrate. You know integration here, x raised to 4 by 4, x square by 2, and then just put the limits. The only this part is important, remember here.